arrays. The arrays in nim are like classic C arrays. Their size is specified at compile time. It cannot be given or changed at runtime. Okay, we went over that a little bit. So we define a type, 3 string addresses, and it's an array of 3 elements where they are all strings. Okay, so they will be index 0, 1, 2. We create a variable names, 3 strings of type that array, so we don't have to retype it again. Okay, we could just copy and paste that instead of here and it will still work. And we create an array. So we have normal square brackets and we put those 3 names. Then we say addresses, 3 string address, and we have the same thing. Okay, what is the difference between those two? I don't see any difference. It's just they need to be 3 elements in there. The size of the array is encoded in its type and cannot be accidentally lost. Therefore, a procedure taking an array of variable length must encode the length in it and its type parameters. So if we want to have zip A and B of array I and T. Okay, so this is generics. We didn't go through that yet, right? Or we did. Generics. We might have touched on that in the last stream, right? I think so. So this is very interesting. I guess I'm not used to a situation where you specify that not only the values that the array is holding, but also the number, and that number is generic. That is very interesting. So yeah, that's fun. And then you say it returns array of the same number of elements. I wonder if you could do I plus 3 or something like that here so that it's pre-calculated or whatever. And tuple, which are tuples of all that. So let's try it. Let's try to see if we can add this plus in there, because this is fun. So we created that zip, and for we iterate over, lowest possible value of A. With the lowest element of the A array to the highest. And we'll basically make sure that each element of the result, the new return variable, because I guess it pre-allocated that array type into our result, the hidden variable. And we just assign a tuple that contains both of them. So, a classic zip. But what's going on here? We let name and addresses equals names. Where did names come from? I see. It was in one of our previous examples. So let's copy this thing and just shove it up here, right? So we define it as that, save it, and now it doesn't complain. Okay, let's do echo name and addresses. And let's see what we get as a result. Okay, so we have first tuple, second tuple, and third tuple. Okay, simple. So let's try let's say that at the end we're gonna add 2 more elements. So we'll do result. It'll be high of A, which is the last. How do I turn it into an index? I is the low of A and high. Okay, so low and high will return an index. It won't return the actual value, it's just an index. Okay, so result will be high of A plus 1, right? So let's call it let highest index or max index, and that will be this thing. So we can do max index plus 1 will be, let's call it hello there, right? I'll do another one, which would be, let's say 2, and another one should be 3. I will just add those 3 values. If I'll try to run it now, I expect to have compile error here because we're trying to add something to an index that doesn't exist. So if I'll run it, there we go. Execution of an external program failed. Unhandled exception index 3, not in 0 to 2. Yep. So can I specify this will be I plus 3? No. Come on. One is type description. One is... I wonder how to do that, because I can see it as, a decent use case where we want to, let's say I want to have the procedure that does something and returns an array that's, combines 2 of them or something. Let's ask AI if we can fix that. I have the following code. Let's paste it here. Please tell me how I can specify the return type to return an array with extra 3 elements. My attempt with I plus 3 doesn't compile. That's a tricky question. If this is gonna answer correctly, I'll be surprised. To specify the return type of the zip procedure to return an array with an extra 3 elements, you can use a generic parameter for the array size. Here's the modified code. So ITN, and we have static. Oh, N is some kind of static integer. Very interesting. And therefore, then we have our A, B, and then we have the return type already specified as N. That's not it. And then we need to assert array size might be greater equal than this. Wait a moment. What is this static? Doesn't mean that that part will be executed during compilation, like a compilation check? Gosh, this language is getting better and better. If that's true, wow. Let's see. Let's replace our procedure here. Save. Now it's unhappy about T. Type expected. Cannot instantiate T. Server failed. Everything failed. Let's just run it. Type expected. And 646. Line 646. Oh, so where's character 46? Column 46. 46 is here. Okay, I don't understand what's the problem now. Because we say that there's I, T, and N, right? Now we say this is I and T, both of them. And then we have N. We have tuple of this and that. And suddenly the T isn't going through. I don't think this is trying to assume that I and T are both static integer. Interesting. And we could iterate from I to N. Wow, that is so strange. But that means that I is also expected to be an integer. And because of that, it thinks T is an integer as well. Oh, so well, if I'm gonna do IN, comma T, save. Oh, better. Cannot instantiate N. What the bleep? Oh, so let's make it actually a first one. So that oh, no. Okay, I don't know. Let's ignore that. I'm going way off here. We just know that we can specify that the same length. Okay. Alternate methods of indexing arrays are also allowed. And the first type parameter is actually a range. Just a value, as above, is synthetic sugar for 0 to n minus 1. So it's also possible to use ordinal values to index an array, effectively creating a lookup table. I just got an idea. Let's get to our original definition, right? This was unhappy because of the I plus 3. But now we know that I here is a range. So what if I'll say that it's from 0 to high of I plus 3? Expect one of first. So I is, how do you find range? Range of integer? Nope, again, nothing works. I thought that would be smart, but nope, never mind. It's also possible to use ordinal values to index an array, effectively creating a lookup table. So we have a type, parts of speech, and we have all that. Let parts of speech examples, an array of parts of speech, and therefore we specify this. So we can call later echo parts of speech, and in brackets we say adjective. Nice. So do we use the parts of speech anywhere? No, let's see. So let's get rid of that. We have parts of speech. So echo parts of speech examples. If we'll print that, we're gonna just get those values, right? But nothing stops us. Echo parts of speech, verb, save, and run. And we get reads because it knows the verb maps to that. This is powerful. Okay, this is very powerful. I really like that. Type. So I specify type mate. Ooh, okay, here we have a static that isn't explained. So define matrix. So I guess we're going to math, something I really don't like, width and height. And I presume they're both static integer equals array, where 1 to w and array 1 to h and integer. Okay, so it's an array of arrays. That's it. So matrix 1 has width of 2 and height of 2. And then we have open and close it here, and we have those two values in there. Okay, that makes sense. And then the other one, and then we can define plus on that, where they're both matrices of the same width and height. Okay, so this, I guess, infers that both width and height are of the type static integer. Okay, for I in 1 to high of a. So iterate over it, and we just add them. Okay, very much like it. And I guess here the printing is defined. So just skipped so we don't have to have it here. So let me grab this and go for yet another attempt, because I just for some reason can't give up and we grab this just to have it up here. So let's say that this I is static and we just say static and integer is in those brackets. That's different. Okay. What? Now it's fine? Why? Why now it's fine? Because I should be able to define just that, right? Static integer as well. Save. And it compiles. Let's grab that code and ask what the difference is. What is a difference between static int and static int in the following context? Send it. They have the same meaning and can be used interchangeably. The static is a keyword used to specify that a parameter or variable should be evaluated at compile time. It allows the value to be known and used during the compilation process. Okay. When defining a generic parameter with static, you can use either static int or static both. Basically, is the same thing. Okay. Directly specifies that generic parameter is compile time. Oh, so it's just a shorthand. Okay. Good. Let's ignore the rest. So we can just specify it like that. This just shows I in there because it isn't aware of a range. So this will work only for arrays where the whole thing is static. I mean, it's just an integer, not something else. So in theory, I don't think we could put an enum here. While if we have this thing, now we can put an enum in there. Okay, I see the limitation, I think. Because if we want to, zip to enums and we want to add additional values at the end, suddenly we can't because, you can just add new values to the existing enum. But let's say that we want to just work on integers, right? We're not doing anything fancy. And we do from 0 to I, and he'll be from 0 to I plus 3. Save. Oh, now it works. Look at that. And we can say that the whole thing, result of A plus 1, and we just, what was it? Hello world. And we just do it 2 more times, 2 and 3. And let's do just echo. And let's try it now. There we go. We did it. We have first one, second one, third one, and then we have hello world, and hello world. And it's all arrays, which are basically with, with a static number, with a number of elements that is predefined during compilation time. Okay, I'll call it a small success. And yeah, this is the thing that helped us here. So I must say this is very powerful that we can specify those parameters and specify those, using those arrays where we can just do that and we'll basically constrain the size of the whole thing. This is pretty powerful. Not the most intuitive, at least for a newbie, but at that point it's really nice.